Hello, so in this section, we're going to look at estimating a population proportion. So one thing that you would have to remember, for instance, is how to find p hat. P hat is essentially just x divided by n. And the other thing that you would need to know, for example, is how do you find what is called the confidence interval? So the confidence interval is essentially taking the p hat and then saying plus or minus z alpha divided by 2 and then multiply this by the standard deviation, which in this case the standard deviation is going to be p times, this should be p hat, times 1 minus p hat, and all of this is divided by n. So this confidence interval, okay, so this confidence interval depends on whatever the size of alpha is, which is usually like 5% or 1% and so on. Um, so essentially, it's kind of like you're looking for a lower bound for this confidence interval. And at the center would be the mean. So you have that you would just need to find p hat minus z alpha over 2 multiplied by the standard deviation of p hat times 1 minus p hat, and all of this is divided by n. So that's the lower part. The upper part would be p hat plus z alpha divided by 2, and then just do the square root of p hat and then 1 minus p hat, all divided by n. Okay, so one thing that we can do from here, so let's look at the first example. And mind you that z alpha hat, you're going to have to use either the inverse norm or whichever the case is. So like for example, whenever you're trying to look for z alpha hat, you will do inverse norm, and the area of which that you have to look for is essentially it's two things either. So either you have that it's gonna be uh, so it's either gonna be 1 minus alpha divided by 2 comma the mean is 0 and the standard deviation is 1. So in this case this is gonna give you equal to the z alpha divided by 2. Okay, so looking at this example, we have that, okay, so we have a few things. We have that x is equal to 185 and n is equal to 385. So what that means is that p hat is equal to 185 divided by 385. Now, if we give the estimate as follows, 185 divided by 385, that's going to be 0.4805. Okay, so that's going to be the p hat, which is estimated to be our mean. Now, we also want to find a 95% confidence interval. So what that means is that, for example, the alpha is equal to 1 minus 0.95, which means that this is going to be 0.05. But because we're talking about a what we call a confidence interval with 95%, we're going to have to divide this by 2. So that means that alpha divided by 2 is equal to 0.025. Okay, so essentially we have our alpha over 2. So this is going to tell us that z alpha over 2 is equal to inverse norm of 1 minus 0.025, comma, the mean standard deviation. So this is going to give us the following. If we go to second vars and we go to normal inverse norm, and then we know what the area is, so it's going to be well, let's do it like this. Let's do 1 minus 0.025, and then we'll just click enter. Okay, now if we do this, it gives us approximately about 1.96. So we have that this is going to be 1.96. Okay, so furthermore, we can actually find our standard deviation. So the standard deviation, okay, so we'll just do it like this. Standard deviation is, so we have 0.4805 multiplied by 1 minus 0.4805, and then we're going to take the square root over, let's see, that's 385. Okay, so, and we're going to have to be very clever with this. So we have 0.4805 multiplied by 1 minus 0.4805. We close it. We divide by 300, or what was it, 385? Yeah, 385. And let's go ahead and take the square root of this. So we have second answer. We click enter, and it looks like it's 0.0255. So we'll just use 0.0255. Okay, so what this means is that we have that the confidence interval plus or minus z alpha over 2 times the standard deviation with respect to p hat. That's going to be, so what did we say p hat was? It was 0.4805 plus or minus 1.96 multiplied by 0.0255. So this gives us, okay, so we just had to figure out what 1.96 is. So 1.96 multiplied by 0.0255, and we get 0.049998. That's not a bad number. So 0.4805 plus or minus, okay, let me just try to recall, 0.04998. Now, if we use this, then all that we need to find is the lower bound. So the lower bound is 0.4805 minus 0.04998. And that gives us about 0.435, 0.43 052, comma, okay, so we need to take basically the same thing but change it to addition. So we just have to do plus, and that gives us a upper bound of 5.53048. Now, what this means is that this is where 95% will lie within this range. So in that case, it tells you like approximately how many people do you expect to have a passport at least, and then up to. Um, and I can verify my answer by looking at the work. So 43.06. Okay, so 4306 and 5304, which is roughly very close. I mean, it's roughly very close to what we have. Let me see. The standard deviation was 0.02546. Okay, so that's why we have a bit of a error in terms of like, um, in terms of like what do we have here. So I mean, it's fine. I mean, we have that basically, if you want to phrase it, you have that there's approximately 43.1% and 53% of junior college students that have a passport. And then that would be it. So you could say like 43.1% to 53.0%. That's the proportion of which that we should expect to have passports. Now, there is another way that you could have done this problem, such as like I believe it's under second distribution. Um, let's see. It might be under stat. So let's see. I think it's Z interval. So you would just have to tell it the data. So like, what was the? Oh no, tell it the stats. I mean, yeah, because we don't know. So the standard deviation. Um, let's see. Okay, so what did we get for the standard deviation? We got 0.0255. So we'll do 0.0255. The mean was 185 divided by 385. And we have that the sample size was 300. And the confidence level was 95%. So we just hit enter. And let's see, why did it give us not really what we wanted? Second. Yeah, sometimes the calculator doesn't give us what we want. Let's see, z-test, no. Actually, I think it might have been because it was a 99% confidence. No, it says 95%. Oh, yeah, sorry. It's 385, not 300. So, yeah, so everything should be correct now. Mm, no, it's still giving us, still not giving us what we wanted. Yeah, so it may be best to just use, um, it may be best just to go ahead and just use the given information instead, because this is not giving us what we wanted, because the confidence level is 385. So yeah, because even if I change it, it doesn't do anything for me. Yeah. Okay, now let's look at an example where we want to determine the sample size needed. So one thing that we will need is what we call the margin of error. The margin of error is essentially just taking the z alpha half and multiplying by the standard deviation. But the standard deviation is p hat multiplied by 1 minus p hat. So like we'll have like 1 minus p hat, and all of this is divided by n. So the one way of which that we can find this, for example, is we just use the given information. So a researcher at a major clinic wishes to estimate the proportion of the adult population of the United States that has sleep deprivation. How large a sample is needed in order to be 99% confident that the sample proportion will not differ from the true proportion by more than 5%? So what this means is that we know that the margin of error is 0.05. Now, the other part of it is that if we have that p hat is not mentioned anywhere in the problem, then we have to use that it's going to be just 1/2 because somehow that maximizes it. The other is that we can find the inverse norm of, for example, 1 minus, okay, so we have 0.99 divided by 2, comma, uh, so comma the mean, which is going to be 0, and comma the standard deviation, which is going to be 1. Now, in this case, like if we go ahead and we do this, then that's going to give us our, our critical value. So we'll go ahead and just do second inverse norm. Second inverse norm. And we have the area is going to be 1 minus 0.99 divided by 2. And then we just go from there. Okay, so I got that the z-score that corresponds to this should be, may not be right, but let's see. Okay, so we want to find the sample size. Okay, so 5% standard error into a 99% confidence interval. So let's see, so 1 minus 0.99, you divide that by 2, and then you just add to alpha, 0.995. So 1 minus 0.99 divided by 2. Yeah. This may be a little off in terms of like how I mentioned how we can get the z-score. So let's do it like this. We're going to take 1 minus 0.99, and then we're going to divide this by 2. But we're going to add this back to, yeah, we're going to have to add this back to the 0.99. you can find whatever method that you prefer to find the 0.995. So, for example, we had 1 minus the alpha divided by 2. So alpha is 0.01 divided by 2. So in this case, like we'll just do second vars inverse norm. Okay, so we'll do this again. 1 minus 0.01 divided by 2. And we'll just hit enter. Okay, so we do that, and there we go, 2.57. So we can just do 575. Really, it should be 2.576 though. Or we could just do 5758. Okay, so z, okay, so is equal to 2.5758. Okay, so let's just be sure. Okay, so we have that z alpha is 2.5758. So what we'll do is we'll just do it like this. We have 0.05 equals to 2.5758 multiplied by zero point 0.5 multiplied by 0.95, or not 0.95, but zero point 0.5 divided by n. Now we'll do this. We'll do 0.05 divided by 2.5758 equals to the square root of 0.5 times 0.5, all divided by n. Now, in this case, what we can do is just say, well, what if we just go ahead and square both sides? So we'll end up with 0.05 divided by 2.5758 squared is equal to 0.5 times 0.5 all over n, which now means that basically we just need to look at this like, okay, well, if we divide n, or solve for n, we have, let's see, we'll have that this is going to be equal to 0.5 times 0.5 multiplied by 2.5758 all divided by 0.05 and then square it. Okay, so this looks like quite a bit, but it's actually not that bad, because if we take 2.5758 divided by 0.05, and then we square that, and then we multiply by 0.5 times 0.5, you're going to get approximately 663.47. So that's going to be 663.47. So all that you need to do from here is just round up. So whenever we're doing the estimated sizes, we just have to be we just have to round up. So if I round up to the next value, because you're trying to maximize it essentially, you have that the sample size must be 664 in order to guarantee those conditions. So as you go ahead and you go through some of these problems, it helps to kind of know the different formulas. Okay, so just be sure that you run through like different formulas that you would have used. And yeah, make sure that this says alpha over 2. Okay, so that's going to be it, and be sure that you kind of just read the chapter and see the different techniques that you can use, because like in this one it was required that we knew the formulas, so you can't do anything if you don't have the formulas. Let me just do that again. Yeah. Okay, so we have that those are the different formulas that you'll